Okay, so hello guys. I'm glad you tuned in to our post-laboratory discussion. So we will discuss what you research and what you have drawn in our principles of enzyme reactions. So to make this discussion efficient, so I want you to get your notebook so that you don't have to watch this video twice. So take down notes, and I promise it will be worth your time. So I will not be repeating concepts that your lecture have already discussed. So mababaw na lang yun, especially the definitions. But I want to delve deeper on Michaelis, Menten, ano yun? Lineberg-Weaver, plot, what else? The competitive inhibitors are inhibitors. So something like that. So I promise I won't waste your time, and we will make our discussion very fruitful and relevant. Okay? So simulan na natin. Okay, so here are just our few definitions. So most probably, baka mas magandang definition sa module nyo. So you can go with that, but we will have just define a few things. So active site. Active site is the one that is in your enzyme, which interacts with its substrate. So it's a hollow area. It's a three-dimensional site where your substrate attaches to your enzyme. Next, substrate. Substrate are substances acted upon by an enzyme. Product. So product are, so when your substrate attaches to the enzyme, so the end substance that is derived from the transformed substrate from the enzyme, so we call it a product. Kasi yung definition ko dito, product, the product derived. So I use the same word, and mali, jelly. And next class, allosteric site. So a cavity other than the active site. So let's say a back door that may bind regulatory molecules and thereby significant to basic enzyme structure. So aside from your active site, we have this allosteric site. So some molecules, so they want to regulate to slow down the enzyme or to inactivate the enzyme. So we have an allosteric site for that. Yeah, and so class, I want you to remember this equation. This equation. So your substrate, so plus the enzyme will form the enzyme substrate. And this enzyme substrate will form a product, N plus enzyme. So class, as you can see in this image class, this is how your enzyme works. Yan. So your enzyme class catalyzes your chemical reactions. It expedites your chemical reactions, meaning it speeds up your chemical reaction. Yan. So it does not activate chemical reaction, ha? So it speeds up chemical reaction by lowering the activation energy. So class, for a chemical reaction to start, you need a high kinetic energy. So if there is a high kinetic energy, guys, your chemical reaction tends to start. Yan. So some chemical reaction spontaneously starts in the body if there is high kinetic energy. But when, class, there is the presence of enzymes, it lowers the activation energy so that it can speed up the beginning of a chemical reaction. Galing, no? Enzymes, class, lower the activation energy. So dati, ang alam nyo lang, enzyme catalyzes the chemical reaction. Now, nadagdagan, it lowers the activation energy. And it lowers the energy barrier. Galing, no? Class. So class, look at yung last part. So product plus enzyme. So notice, class, your enzyme remains unchanged. Buo pa siya. Yan. So despite the substrate attaching to the enzyme, forming the enzyme substrate complex, and forming the product, the enzyme retains its shape. Yan. So buo pa siya. Nagtira siya para sa sarili niya. Charets. Okay, next. So we have characteristics of enzymes. So enzymes are invariably invariably complex proteins. Yan. Enzymes are big proteins, class, and they are amphoteric by nature. When we say amphoteric, sa madaling salita, it can act as both an acid and a base. Yan. Enzymes can be easily denatured just like any other protein. It is soluble in water, glycerol, and dilute alcohol. It's colloidal in nature and are not dialyzable. So meaning it cannot pass through your kidney and usually function with a cofactor. Yan, itong mga, huwag niyo kakalimutan dito mga terminology na to. So we have inorganic cofactors, also called as your activators. So class, these are the one that activates your enzyme, ha? So we have chloride. So mali yung pagkasulat ko ng chloride. Small letter yung L, class. Magnesium, so we have metal ions. We have organic cofactor, sorry, sa typo ko. So our coenzymes and NAD, that's NAD. Yan, mamaya pag-usapan natin yung organic cofactors kasi we will encounter that in the laboratory. So now, class, so more of the characteristics of your enzyme. Let's get to know it better. So enzymes are neither consumed nor produced during the course of a chemical reaction. So it's still intact after a chemical reaction, as you can see in our image in the previous slide. What else? Enzymes do not cause reactions to take place because reaction can happen at high kinetic energy. They expedite only reactions. So class, I told you, so chemical reactions can spontaneously happen as long as there is a high kinetic energy. But if your enzyme is there, it lowers the activation energy for a chemical reaction to start. So the chemical reaction will be faster because it requires lesser energy. Yan. So ibig sabihin, class, nung kailangan, sabihin natin, high kinetic energy. So, ibig sabihin, kailangan ng maraming gasolina para gumana ang isang chemical reaction. Pero pag sa enzyme, class, naka-diskwentro tayo. So, nabawasan yung energy requirement pag andyan ng enzyme. Yan. So, enzymes are an asset. Next, class, enzymes catalyze physiologic reactions by lowering, yun na nga, the activation energy level that the reactant substrate must reach for the reaction to occur. Yun na yun. Okay. Naulit. Yan. Enzymes are invariably proteins, amphoteric, both have a positive and negative charge. Yan. They act both as an acid and pH, an acid and base. Yan. Enzymes, class, are highly specific for the reactions. Yan. They are highly specific. So most of the time, if there is a chemical reaction, they do not have other side reactions. Yan. They are highly specific. Produce only the expected products from a given substrate. So class, sabihin natin, enzyme is very safe. Sabihin natin. Yan. Hindi siya, it is consistent. Yan. Very safe, very consistent. So if it reacts to a certain substrate, it will give a certain product. Yan. There's no side reaction, di ka magugulat. There's no mutation or anything like that. Class, according to Bishop, meron siyang mga term. Absolute specificity. May enzymes daw that they have absolute specificity, wherein they have high specificity toward only one substrate. Yan, one lang yung substrate niya. We call it absolute specificity. But some enzymes have broader specificity towards a substrate. So example, if it has group specificity, it can act upon substrates which has phosphate esters. Yan. Lahat ng may mga phosphate esters, pwedeng mag-active site sa enzyme na yon. Yan. Pwedeng mag-active site, pwedeng mag-attach or interact with that enzyme. Yan. So that's group specificity. Yan. That's based on Bishop. Class, so reaction catalyzed are frequently reversible. Yan. It can be reversed. Enzymes are easily denatured by pH and temperature. Enzymes are synthesized in an inactive state. So the inactive state of an enzyme, what do you call an inactive enzyme? Yan, diba? Nasa notes yan. Baka sa akin nyo. Yan. So class, we have the different classifications of your enzyme. Please get to know them. We have the group of oxidoreductases, transferases, hydrolases. Class, in our next laboratory activity, we will discuss AST and ALT. So they are transferases. Yeah. So this enzyme class they catalyze the transfer of functional groups. Yan. Transferases ang next na topic natin. Exciting. So class, we will now talk about enzyme kinetics. Yan. Kayang-kaya natin to. Take a deep breath and out. So when we say enzyme kinetics class, we talk about the rate of chemical reactions, the rate or the speed of chemical reactions. So, ma'am, what are the factors that affect the rate or the speed of your enzyme reactions? So, number one, class, we have substrate concentration. Substrate concentration. We will explain that further through Michaelis-Menten curve. Yeah. Next class, we have enzyme concentration. So class, direct relationship with the rate of reaction. So class, if you increase your enzyme concentration, the rate of the reaction increases as well. Yeah, very basic. Next class, temperature. So class, temperature and pH, class, your temperature and pH. So if you get if you will react certain enzymes at undesirable temperature and pH, it can cause denaturation and change in ionic state, which causes, so change in ionic state results to change in molecular arrangement. Yan. Mag-iiba yung molecular structure, molecular arrangement. So first is temperature. So we have this term Q10 value. So refers to the increased rate for every 10 degrees Celsius. Yan. So, Q10 value means the rate of reaction is doubled every time you raise the temperature at 10 degrees Celsius. But if you will exceed up to 50 to 60 degrees Celsius, your enzyme will be inactivated and denatured. Yan. So, if you started with 0, and incrementally increase the temperature to 0 to 10 degrees Celsius, to 20 degrees Celsius, to 30 degrees Celsius, to 40 degrees Celsius, plus the enzyme reaction just speeds up, and the rate increases. Yeah. But once you reach 50, 60, 70 degrees Celsius, 100 degrees Celsius class, it becomes inactivated and denatured, just like any other protein, guys. Diba? Protein ang enzymes. Next class, we have pH. So, class, your enzymes, most of them acts at pH 7 to 8. So, that's their optimal pH level. But class, we have this enzyme that are choosy with their optimal temperature at optimal pH. We have pepsin. So, pepsin is found in the stomach, diba? So, pepsin is active at pH 1.5, so very acidic. And ALP is alkaline phosphatase. So, alkaline phosphatase. So, from the word alkaline or alkaline phosphatase class, it loves a basic environment. So, at pH 10.5. So, class, we will test for alkaline phosphatase one of these days in the laboratory. And class, so we will make sure that if we're going to test for this enzyme, that the pH or its environment will be alkaline. Yan. Meron pa tayong acid phosphatase. Yan. So this acid phosphatase, so the opposite of alkaline phosphatase, so it requires an acidic environment. Ganyan. So as medtechs, yun yung mga tinitingnan natin. So kung na-contaminate natin yung mga specimen natin or reagent with an acidic substance, so it can denature or it can inactivate your ALP. Yan. So in class, we have this activators, yung chloride, yung magnesium. Okay, so now here, so we're going to focus on Michaelis-Menten kinetics of enzyme reaction. I think parang ito yung culmination ng discussion na to. Don't worry guys, it's very easy and we'll make it easy for you. So basically class, when it comes to your Michaelis-Menten kinetics of enzyme reaction, so it's simply about the substrate and velocity of enzyme reaction relationship. So the relationship of substrate and the rate of reaction of enzymes. Yan. So class, to make Michaelis-Menten happen, so it could be, so we could show it in this plateau right here, in this graph right here. So your enzyme concentration should be constant. Yan, wag mo papalitan yung enzyme concentration. So ang nagbabago dito class, substrate lang. Yan, substrate. So class, in this graph, so in the x-axis, so that's your substrate concentration. Yan, very basic, substrate concentration. Sa y-axis class is your speed. Yan. So class, syempre, since ang pag-uusapan natin, mag-focus dito sa substrate concentration. So what can be the impact of your substrate as you increase the concentration of substrate? Yan. Anong mangyayari sa speed natin or sa velocity? Basically, yun yung gustong i-compute ni Michaelis-Menten kinetics. Yan. Okay, so let's read the second part. So the reaction rate steadily increases as more substrate is added. Yan. So, yan. So class, as you increase your substrate, yan, tumataas, nasa-speed up ang ating reaction. But class, the substrate concentration, if the substrate concentration is high enough to saturate all available enzyme, the reaction velocity reaches its maximum and it is called zero order kinetics. Yan. But at some point, class, at some point, your substrate will saturate all the available sites in your enzyme. It will, ibig sabihin, all enzymes are busy to participate. All enzymes are actually in act right now. So, wala lang natirang enzyme para mag-react to, kahit paramihin mo yung substrate class, you can just, there is already a threshold for your enzymes. Yan na nabuno mo na yung enzyme class and you already will reach a maximum speed for your chemical reaction. Yan. Bigyan natin ng isang example. So example is you have your Aurora Hill Jeep, your Trancoville Jeep, or your bus. Yan. So we have this transport. So ano kaya? Jeep na lang. So this jeep, alam niyo naman ng jeep glass. Pag wala pang pasahero ang jeep, pahinto-hinto pa yan. Yan. So let's, in this metaphor, our enzyme is our jeep. And our active sites are the passenger seats of the jeep. Yan. So class, 'di ba, ang jeep, pag wala pang laman yan, pahinto-hinto yan. Yan. So kasi nagtatawag pa yan ng mga pasahero or sabihin natin, in this case, your substrate. Yan. So class, pag parami ng pasahero or ng substrate sa jeep, class, pabilis siya ng pabilis. Yan, pabilis ng pabilis. At some point, class, mapupuno na yung jeep na hindi na siya bibilis. It has reached its maximum velocity. Yan. Since sa highway naman, class, may limit ang speed natin. So, your jeep class will be consistent in its speed. Yan. Hindi na siya bibilis, hindi na siya pwedeng bumilis. At since puno na yung jeep, so same thing class with your enzyme. So at first class, so as you increase the number of substrate in your enzyme class, so as you increase the substrate concentration, so it gradually speeds up. Yeah. But as you saturate all the places in all the active sites in your enzyme, eventually it will hit a plateau. Yan. It will hit a threshold. And that threshold, we call it maximum velocity. Yan. So notice class itong curve natin. So yung first order kinetics class, yan, first order kinetics, let's get a pointer. Nito. Ano nangyari? What's this? Lumabas yung presenter. Wait lang guys. So let's get a pointer. Yan. So this is first order kinetics, itong first part na to. So first order kinetics, so the reaction rate steadily increases as more substrate is added. Yan. And class, at some point, you will reach your Vmax or your maximum velocity. Yan. You will hit itong line na to. You will hit a threshold. Yan. You will hit your maximum velocity. Ito na yung pinakamabilis, guys. So, once you place more and more of your substrate, kasi kahit maglagay ka pa ng maglagay ng substrate class, the velocity has reached its maximum and it will not increase anymore. So Vmax is your maximum velocity. So maximum velocity or your zero order kinetics will happen once all your substrate has saturated your enzymes. Yan. Very simple, diba, class? Gets nyo ba? And class, very simple rin. Km. Ang ibig sabihin ng Km, class, is 1/2 Vmax. Yan. 1/2 Vmax. Yan. Km means 1/2 Vmax. Class, the lower the Km class, the higher the affinity of substrates to your enzyme. Class, habang mababa pa lang ang Km, naku, dikit na dikit ang substrate sa enzyme. Your substrate has high affinity to your enzymes. Yan, dikit na dikit siya. But class, as you go higher, yan, mas namataas yung Km mo as you go higher. As your Km increases, class, the affinity of your substrate decreases because, diba, it slowly saturates all the active sites in your enzyme. Yan. Like, no? Class, naiintindihan nyo ba? So, ito lang yung mga terms natin. So, we have first order kinetics. So, as your substrate, so wala ka pa nalagay na substrate. And as you add more substrate, your chemical reaction, your rate of chemical reaction increases. But once your substrate has saturated all your enzyme, you will reach already a threshold of your maximum velocity. You will reach a limit of the maximum velocity and you call it a zero order kinetics. Yan. So Vmax stands for your maximum velocity, the speed threshold. Ibig sabihin yun yung limit, yun yung pinakamataas. And we have this Km. So Km is half the Vmax. Yan. So in this yan, the higher the Km, the lower the affinity of the substrate. So pag tumataas ang 1/2 Vmax natin, class, yan, ang substrate, hindi na siya makapit. It has low affinity to your enzyme. But if your Km, class, is low, dito ka nag-0, tapos patas ka ng patas dito, so your substrates still have high affinity to your enzyme. Class, diba? Ganun lang kadali. So if you didn't understand, ulitin mo lang itong slide na to, okay? So next, bakit merong anyway, so now, isingit natin itong mga inhibitors. Yan. So class, may kalaban ng ating substrate. We have these inhibitors. So first off, we have competitive inhibitors. Competitive inhibitors. Wow. So it competes with substrate to bind in the active site. It competes daw with your substrate. So agawan sila ng place sa puso ng enzyme. Yan. Sa active site ng enzyme. Class. And we'll just note that though there is a competition with the active site, the same Vmax remains. Yan. The height of the Vmax remains, but the Km increases. So the Km increases, meaning since may kaagaw na competitive inhibitor, the substrate becomes the substrate now has lower affinity to your enzyme because your Km increases. Yan, because there's an inhibitor. Okay. Discuss ulit natin yan mamaya. At kasi babalik yan mamaya. So class, next, we have non-competitive inhibitor. So, ang inhibitor na to, ayaw makipaglaban sa substrate for the active site. Ayaw niya yung active site. Ang gusto niya mag-attach sa allosteric site. So, allosterically binds the enzyme elsewhere from the active site to inhibit the enzyme. So, class, hindi competitive, it's non-competitive. It does not compete with to the active site. However, guys, mas matindi to. It inhibits the enzyme or it disables or inactivate the enzyme. So, class, ang effect nun, bababa yung Vmax natin, yung threshold natin, yung speed natin. It lowers the Vmax, but the same Km, the Km remains. Yan, it's unchanged. Therefore, your substrates still have high affinity to your enzyme. However, class, hindi na ganun kabilis yung chemical reaction. Gets nyo ba? Galing, no? Class? And amazing how they can measure the speed of chemical reaction. Next class, we have uncompetitive inhibition. Uncompetitive. So in which the inhibitor binds to the ES complex. So not in the active site, not in the allosteric site, but through the ES complex. Increasing substrate concentration results in more ES complexes. Yeah, it binds in the ES complex. What happens is it decreases both your Km and Vmax. So this is worse when we say uncompetitive inhibition. So Km, so your Km class increases both Km, diba? Pag Km, bumaba ang Km, so mataas ang substrate affinity and decreases Vmax. So your rate of reaction is slower. Yeah. So class, so this is just a illustration of your competitive inhibition. So, yung inhibitor at yung substrate naglalaban sa sa active site ng enzyme. Yan. So, one way to overcome this, yan, inhibitor is overcome by increasing substrate concentration. So, apparently, there is a competitive inhibitor in your chemical reaction. Yan, nasa laboratory ka at may inhibitor. So, to troubleshoot that or to prevent na may mga inhibitors, class, just flood it, increase the concentration of the substrate. Yan, increase the concentration of the substrate. So, that's the troubleshooting or solution if there are competitive inhibitors. Yan. Next, we have dito muna tayo, non-competitive inhibitors. So, non-competitive inhibitors, so the inhibitor attaches at the allosteric side. Yan. So, ayan class, yung inhibitor. So, nasa ibang site siya, hindi siya nasa active site. So, class, may note ako dito, inhibitor is not overcome by increasing substrate. So, class, even though you increase your substrate all you want, yan, you will not cancel out your inhibitor. And we have this uncompetitive inhibition. So, when we say uncompetitive inhibition, class, the inhibitor attaches at the EX complex. Yan. So, class, if you're going to look at your mechanism, then madali lang to, class. So, this is your normal enzyme chemical reaction, di ba? Ito yung first order kinetics, ito yung zero order kinetics. So, class, yan. Kanina, sabi natin sa competitive inhibitor, the Vmax is still the same. Yan. The Vmax is the same, but the Km becomes higher. So, it's actually not good when the Km becomes higher because the substrate would not has lower affinity for your active site. Yan. Same Vmax pa rin. So, the solution is just add. So, ang good news, class, sa competitive inhibitor. So, if you added more substrate, the enzyme can function at a high speed pa rin. Yan. Mabilis pa rin siya kasi same Vmax nga pag competitive inhibitor. Ito, class, ang problema pag non-competitive inhibitor. So, notice our this kind of curve. Yan. So, bumaba na. Yan. So, Vmax is almost halved. Yan. Magkapareho na sila ng Km. So, ang baba na nila. So, ibig sabihin, there's something wrong with the speed of chemical reaction when there is a non-competitive inhibitor. Yan. There is a lower Vmax and the same Km. Yan. So, the substrate has still high affinity for the active site. However, class, the enzyme is inactivated or inhibited due to the inhibitor, non-competitive inhibitor or disabled, bumabagal siya. So, mas mas problema if there is a non-competitive inhibitor. Yan. Galing, no, class? So, by the way, class, this is the Michaelis-Menten equation. So, initial velocity is equal to the Vmax times your substrate concentration over your Km, so half Vmax plus plus substrate. Yan. So, yan. So, substrate concentration at half Vmax. Yan. Class, yan ang Michaelis-Menten. Yan. I'm showing this equation. Why? Because, class, actually, we have Lineweaver-Burke equation. Lineweaver-Burke equation. Honestly, for me, your Lineweaver-Burke equation, I have difficulty understanding this. Mas mahirap siya intindihin para sa akin pag compared to Michaelis-Menten. But class, actually, it's actually easier. Yan. It's actually, madali lang siya. Yan, promise. So, in class, Lineweaver-Burke equation. So, they said that your Michaelis-Menten class has a limitation because it's a curved line. Yan, medyo curve siya eh. So, there is a difficulty in to really be exact in measuring your Vmax and Km. So class, itong mga mathematician nito, itong mga big brains na to, class, so they made a solution because if it's a curve, it's difficult to measure. Yan. So we can be precise, sabi nila, if we use straight lines. Yan. Straight lines ang pag-graph natin. So they created Lineweaver-Burke equation. Actually, class, so from Michaelis-Menten equation, it's the same. Yan. It's the same. It's almost the same with Lineweaver-Burke equation. And what they did is just, they made it as a reciprocal. So, imbis na VO, class, ang ginawa nila, 1 over VO. Yan. So, class, ni-reciprocate lang nila, double reciprocal plot, nilagyan nila ng 1 as a numerator, tapos yung VO, ginawa nilang denominator. Yan. So, ganun yung ginawa nila. So, 1 over V equals Km. So, yung Km kanina nasa taas, ay nasa baba, diba? Now, nasa taas na siya. Km over Vmax times 1 over substrate plus 1 over Vmax. So, they made it as a reciprocal. So, double reciprocal plot of Michaelis-Menten constant. Yan. So, because they want to plot it as a straight line, actually, class, this equation is a linear equation. Kung naaalala nyo yun. Naalala nyo ba yun, class? Linear equation. So, if something is a linear equation, you can plot it in your x and y axis. Class, so, ang tagal ko nang hindi nag-high school, yan, we discuss about linear equation. So, yung linear equation, class, is, yung general formula nila is y is equal to mx plus b or plus c. So, linear equation. So, yun. So, once you got your linear equation, you can plot it in a grid in your x and y intercept. So, ito yung ginagawa nila dito. Yun. Galing, no? Class, galing naman itong mga to. Sabi nila, ayaw nila ng curve. Gusto namin straight para mas maging precise. Let's make the Lineweaver-Burke. Wow. So, class, let's just show the differences from your Michaelis-Menten and your Lineweaver plot. But yung concept still the same pa rin. So, magkaiba lang yung pag-plot. So, class, ito yung normal natin, yung blue lines, yung normal natin na enzyme reaction. So, nag-iba lang. So, nag-iba lang yung position niya. So, competitive inhibition class. So, yung Km increase natin, Vmax is unaffected. Yan. So, since your Vmax is unaffected, nag-intersect sila dito sa Y. Sa Y area. Yan. Class uncompetitive inhibition. So, your Vmax is reduced and your Km is reduced as well. Since reciprocal nga at class, tumaas. Yan, tumaas. Yan. So, your Vmax is reduced. Next class, your Vmax is reduced and your Km is unaffected. So, dito sa 1 over substrate sila nag-intercept. Yan. So, class, at least, diba, there's some meaning in what you have drawn. Yan. I hope you've drawn this, ah. So class, we have a classification of frequently quantitated enzymes, and so this is summary. I don't know. Saan ko ba nakuha to? Henry or Bishop? Anyway, class, it's in your module. Yeah. So class, in connection with your laboratory, so how is enzyme activity measured outside the body? So we measure the catalytic activity. So the catalytic activity is related to the concentration of the enzyme. So class, honestly, honestly, we do not measure the enzyme as well. The enzyme per se, mahirap class i-measure ang enzyme. So ang mini-measure nga natin is yung catalytic activity. Example, itong apat na to. So we measure using our spectrophotometer if there is an increase in product. So yung product yung pwede natin i-measure. Decrease in substrate. Decrease in your coenzyme. Example, your NAD, which is what we usually measure, especially in your transferases, AST and ALT. Increase on concentration of altered cofactor. Yan, altered cofactor. Ano ba yan? Sorry, nakalimutan ko. So, increased concentration of your altered cofactor. So, example class, this is your Carmen method for your AST. So, ito yung next na laboratory activity natin, class. So, I recorded a video of AST. So, class, this Carmen method is a coupled enzyme reaction. So, coupled enzyme meaning we use two enzymes. So, we have AST and malate dehydrogenase. Sabi niya, at 340 nanometer, the oxidation of NADH to NAD is monitored. Tama. So, Carmen method class uses malate dehydrogenase and monitors the change at 340 nanometer. So, class, ang mini-measure natin dito itong spectrophotometer kasi mas madali i-measure to kaysa yung enzyme. So, yung NADH, mag-oxidize siya into NAD at 340 nanometers. So, class, mostly of your enzyme reactions, class, so mag-stay tayo sa 340 nanometers. Yan. And it's kinetic mamaya. Pag-sabi natin. So, class, these are just the few things that you have described in your QFR. Baka mas maganda pa yung definition nyo. And I read your module. Maganda rin yung definition niya. So, we have examples yung mga define nyo. So, fixed time reaction. A two-point reaction mode in which measurements are taken at specified times. If you remember, class, when we tested your glucose in your clinical chemistry 1, yan, fixed time reaction yon. So, endpoint. So, after 10 minutes, we will read, tapos ang kwento, one reading lang, ganyan. Next class, we have continuous monitoring method or kinetic assays. Yan. Ito yung mga, these are the methods that we are going to encounter with our transferases. Kinetic assays and continuous monitoring method. So, what we do, there are multiple measurements. Yan. Ang ginawa ko, 4 na readings. Usually of absorbance change. So, what we do is we measure for absorbance change. So during the reaction, either at specific time intervals, usually every 30 seconds or 90 seconds, or continuously by a continuous recording spectrophotometer. So class, swerte kung yung spectrophotometer, siya na nagre-read ng sarili niya. But what I did is I manually read the readings every 60 seconds. So, ang tagal-tagal kong naghihintay. Yung isa every 90 seconds. Yan. So, yun, fast forward ko na lang, inedit ko na lang. And next class, we have international unit and Catal unit. So, what we're going to use as a unit is usually international unit U. Yan. So, yeah, class, you just read those. And if I haven't mentioned some things, you can read your module and you can, meron naman kayong lecture, diba? So, I appreciate, class, that you're listening right now. And I wish and I hope that you've learned something. So, you can ask anything. And so, if I cannot answer it, most probably it's in Google. So, thank you guys for listening and salamat. So, stop recording.